udahlah aku nggak usah sebutin semuanya, bisa kayak tunjukin aja udah, and this is the final setting of the model, udah jelasin tuh makin lama lagi. Ya, harusnya bisa, kalau itu nggak aku jelasin bisa nge-cut nggak nyampe 15 menit sih, tetap paling nge-cut lumayan, tapi nge-cut berapa 3 menit mungkin ada, mungkin aku tunjukin aja udah. Prosesnya apa yang mana udah bisa, prosesnya itu juga system solution, udahlah itu aja. Tadi yang pertama siapa, Arkan ya?
Iya, Arkan. Vincent, hostnya kelempar ke kamu, boleh dibalikin nggak?
Bentar. Arkan sampai gimana cara balikinnya, Mas?
Klik di participant list itu, klik more, terus add assign as host.
Assign as host. Make host ya?
Ya, thank you. Kamu ada kamera kan?
Ada.
Oke, belum muncul soalnya. Coba.
Bentar. Belum kenalan. Dah.
Oke, nice. Waiting for Sir Don ya, Sir Satrio.
Mual. Oh, ini di live di YouTube nih. Aku pikir di upload.
Kan aku udah tanya tadi.
Oh, aku pikir itu maksudnya di upload publik. Ternyata maksudnya live streaming publik.
Gak apa-apa kan, kamu kan ininya tesisnya live stream kan?
Ya, aku kasih ke temanku ya, berarti. Bentar ya, Miss. Aku pikir itu maksudnya di upload publik. Ternyata udahlah. Ini udah siap juga kan. Nah. Kita defense kenapa nggak pakai almet ya, Miss? Nggak boleh pakai almet ya? Nggak pakai almet.
Ya, almet kan warnanya apa? Merah ya?
Merah. Yang binus biasa tapi pakai almet, Miss.
Biar nggak usah beli lagi. Kan kamu biar keren, pakainya hitam.
Berat, Miss. Ini punya papa soalnya. Nggak punya warna hitam.
Untung setengah ya? Untung setengah kelihatan.
Nggak punya warna hitam, aku perak ada ya. Berat tuh.
Ini ya, memang di live stream ya?
Ketahuan ya tadi rahasianya di live streaming ya.
Tahu dia katanya soalnya tesisnya tentang live streaming kan?
Enggak juga sih. Tapi kayaknya
mau dikasih ke
temanku
temennya tuh kan. Mau dilihatin ke temen.
Ketahuan ya tadi pakai jaket siapa.
Dan
Bapaknya denger.
Ntar temanku takut nih dengan galak-galak.
Okay. So, because it's already 10:30, should we start?
Should I? Yes.
Okay.
It's okay.
Yeah. I'm gonna open the session. So, good morning, Vincent, Joyan.
Good morning, Miss. Good morning, Mr. Pradono.
Yeah. Good morning to Ms. Nurul and Sir Satrio Pradono. Today we have defense of Vincent Joyan Sutandijo with this title, Artificial Intelligence-Based Automatic Live Stream Chat Translator. How to pronounce it? Sek to sek? Joyan? Sek to sek? Is it correct?
Yeah.
Hello? Yes.
Sequence
Okay.
to sequence.
Sequence to sequence. Model with LSTM, variant RNN, bidirectional language model, and attention network. Yeah. The rules for this defense seem like in pre-defense, you have 20 minutes in total to do the presentation plus the demo. After that, we will have the question and answer session. All right, your time start from now, 20 minutes from now. Thank you.
Okay. There, is it already shared?
Yes, I can see it.
Okay. So good morning, everyone. My name is Vincent, and today I'm gonna present you my thesis. It is a collaborative work with my partner Jason Christopher. It is artificial intelligence-based automatic live stream chat translator, with me focusing on the AI model, specifically using sequence-to-sequence model with long short-term memory variant of recurrent neural network, bidirectional language model, and attention network. So for the accessing problems, there are a number of problems that have become the root in my thesis. The first one is the EF survey from 2017 showed that the Indonesian English proficiency itself has an average score of 52.15 behind those from our neighboring countries. And many of the global major live streaming and video sharing platforms are from the USA, in which they also use English language and as the main medium of communication. And YouTube specifically had around 31.43% of Indonesia's social media market share as of February 2021, and it is only beaten by Facebook, but it is also from the USA, of course. And English contents on YouTube furthermore generates more interaction compared to those with non-English contents. And to support these facts, the authors and his partner Jason also conducted a survey, and the survey shows that the majority of the respondents watches their favorite live stream on YouTube in English and Indonesians, and the language difference has become the most common difficulty faced by the majority of the respondents. And unfortunately, despite that facts, major live streaming and video sharing platforms still do not have automatic chat box message translation supported natively in their program. So this is the example of live stream. As you can see, people from many languages can gather in one live stream chat. But as of today, many live streaming platforms still do not have automatic translation supported natively, like in their program. So people have to rely on third-party translation service to translate it one by one. For the existing solution, there are numbers of existing solutions that have been compared with the outer solution. The GNMT is used by the Google Translation Service, and it is based on the neural machine processor-based design, same as the NMT solution and the outer solution. While the kit translation and the hierarchical is based on the phrase-based machine translation-based design. And for the architecture, the GNMT also uses the same sec-to-sec model with LSTM RNN and mixed unidirectional attention mechanism and beam search. As for the NMT and outer, it is less complicated, but the NMT uses the GRO variant and unidirectional language model, while the outer uses the LSTM and the bidirectional. As for the kit and hierarchical, basically all of the PPNT solution, it uses N-gram language model with modified Nissan smoothing with the kit translation added like a bunch of other language model, and they were discriminated word lexicon as a feature model to increase the accuracy of the translation. while the hierarchical uses weighted synchronous context-free grammar as a transition model, and GKI parser and also Vincent. For the GNMT, it uses BMT14 and the internal dataset from the Google itself, and also 15,500 sample for the testset scraped for Wikipedia and news portal, while the kit translation uses the reported dataset around TED, NC, IPPS, Common Crawl, GigaWord, and English news word discussion. And the hierarchy uses FEIS, Sigma GigaHertz, and NIC dataset for the development and testset, and the NMT solution only use Tatoeba, while the outer solution uses a combination of Tatoeba and an identic dataset. For the data representation, the NMT solution basically converts the dataset and the full sentence into vocabulary of word base or words to integer ID for the NMT solution, and for the outer solution, it's converted into word to one-hot encoding factor. While the kit translation, all of the PPMT basically uses the same n-gram words of phrase table or phrase pair. As for the existing solution, based on the previous comparison, the author says that the neural network design works better than the n-gram language model used by the PPMT due to wider space data representation. Like, what does it mean? Basically, like the NMT solution, uses full sentence and then converted into their respective solution, like word base, integer ID, or one-hot encoding factor to represent the data. While the PPMT solution, it doesn't use like full sentence, but instead a pack of n-gram words, phrase like this 4-gram words of phrase table, and therefore it cannot see like beyond those n-gram words like 5-gram or 6-gram. So the capability is limited. And the GNMT requires a greater scale of resource compared to outer solution to achieve the same promised result. And this identical or same scale of resource simply is not available for to the outer. And the outer solution compared to NMT solution offers bidirectional language model as opposed to unidirectional, and also a bigger data set to present. As for the research methodology, the research starts from the literature review, in which the author finding any suitable study to support the theoretical foundation and compares it with other studies. And then continue by data collection, finding any suitable data set to support the training process of the AI model and pre-processing it, but modifying according to need before being fed, and then building the AI model using the PyTorch framework. And then the training process starts with the evaluation periodically sees the validation or the development dataset to optimize the loss value or evaluate the performance. But if the blue method is satisfying, it will goes to the test data evaluation. Otherwise, it will start from the early training process and modifying the hyperparameter. And the result will be in blue score and loss rate report in form of graph. And then it will be used as an evaluation method. As for the proposed solution, basically this is the overall view of the proposed solution. As you can see, very delicious food. It is processed serially being fed to the network. Therefore, the very delicious food is it's processed. It's divided into a sequence of word tokens, with each word converted in automatically by the PyTorch into the representation of integer one-hot encoding factor. And then, as you can see, as a proposed solution uses the bidirectional language model. There are two representations, the left to right and the right to left. And then at the first time step, the leftmost and rightmost of the word tokens in the sequence are fed to the network, and then the same practice continues for the next token until all of the tokens in the sequence are fed, and then the hidden state of both direction will be transferred to the decoder, and then the decoder also applies the same bidirectional language model to process these two both direction of hidden state. And then at the first time step, it uses start symbol to signify the start of decoding, and then the resulting hidden state from these two directions will be concatenated into one hidden state. And then any contextual extra contextual information gained from the attention will be further concatenated into this final hidden state to add accuracy. And this attention has their extra information from the hidden state of the encoder, and then producing the prediction. This prediction will be used as the input for the next time step, and the practice like follows until the end symbol is found. And as it is used teacher forcing to speed up learning process, the input is used from the third time step is incorrect, and therefore it uses ground put instead to speed up the learning process. But at the end, the final answer will be still from the incorrect. It still rethinks. It's just to speed up the learning process. For the data set, it uses Tatoeba project from Tatoeba, the first data set, and containing 7,000 sentence pair. And this is used because it has remote similarity with the live stream chat, which is short in length. And the second one is the identity corpus containing 27,000. And this is used because it has many training points that can be learned by the translation model, and the topic varies ranging from news article and movie subtitles. Therefore, it offers a wider vocabulary. And the datasets are combined from these two datasets and split using 80-20 principle for train, validation, and test set. For the pre-processing, the dataset is divided based on the line separator and resulting in a collection of line separated sentences, and each sentence will be normalized, removing like any number, any symbol, and any except for the period, exclamation, and question, and also separated into this based on the type separator into a collection of this sentence, and then it will be filtered based on the maximum required length and the list of forbidden words stated by the author, and then the sentence, the list of sequence, the list of word tokens after it is divided at this step of pre-processing is converted into its integer ID representation. And this integer ID representation will be grouped into a number of unique batch, and before being fed to the model, it will be converted again into a sequence of one-hot encoding factor. For the evaluation, the author uses loss rate, BlueScore, and Grammarly, and the BlueScore guideline is from the Google Cloud. And this is the final setting, which is used by the author to present the final result. And yeah. And this is the result from the English-Indonesian language pair. The loss rate is in the test set is rated at 3.44, and while in the validation set is rated at 3.149, and the train set is rated at 0.98. As you can see in the graph, the loss result it exhibits an overfitting behavior. As for the BlueScore of English Indonesian, the test set is rated at 0.05, and the validation at 0.07, and the train is at 0.18. And therefore, the model reaches the level of almost useless based on the test set score and the Google Cloud guideline. As for the Indonesian English language pair, the test set is rated at 3.38, the validation at 3.13, and the train set at 0.7. And the loss result also exhibits an overfitting behavior. For the blue result of Indonesian English, the model reaches the level of almost useless based on the test set score and the score of the guideline from the Google Cloud. And this is the result for the Grammarly itself. The Grammarly scores is rated at 19 out of 100, with the readability score at 89, and there are like 263 mistakes in the prediction that are suggested by the Grammarly. And as for the vocabulary, compared to other Grammarly user, the unique words appearance is rated at 25% below average, and the rare word appearance is rated at 18% below average. Based on all of the results and the experiment conducted by the author, like the author says that the model with higher teacher forcing gives off higher BlueScore with less epoch needed at the expense of overfitting behavior compared to those settings with lesser teacher forcing ratio. Despite using teacher forcing ratio to give off higher BlueScore, the performance is still underwhelming, and this is presumably caused by two things. First, the model hasn't set optimal solution to the dataset due to hardware limitation, and the use of combined dataset with the lack of any selective preprocessing leads to appearance of noise data that affect the prediction. And two concerns are faced during the experiment: the limited hardware bound and finding an appropriate dataset, such as the dataset that is directly sourced from the live stream chat log. It is not available currently in the internet from the finding of the author, and therefore the author uses the alternative data set which has remote similarity with live stream chat and offer much more wider vocabularies. And so the conclusion, the author successfully built the translation models, and it performs the automatic translation from incoming English to Indonesian and from incoming Indonesian to English. But it is with underwhelming performance. The underwhelming performance itself presumably caused by the limited hardware bounds and the lack of appropriate data set, coupled with lack of selective reprocessing to the current data set. And for the recommendation for any future study, the author hopes that instead of using an online IDE to develop the AI model, it might be best to try renting for the hardware directly from the cloud service provider, as the hardware can be directly customized based on the need. And if there is no qualified parallel corpus to be found, it might be best to start the thesis from building the parallel corpus from raw data or monocorpus instead. Yeah, that's all from my presentation. Thank you. And ini continue directly to the demo, yes?
Yes.
Demo. Wait. For the demo, so it is because it's already connected to the Google Drive, I just need to log in into my Google Drive. I just need to log in. Sign in. Copy. Input for example using ID and from Indo to English, and then just type whatever you want to translate. For example Indonesia, ya, selamat pagi, and then and the result will be out like good morning. For example, if I use the ENID insert, for example, how are you? And then the results will be out bagaimana kabarmu. So basically, that's the result of the AI model. Maybe Miss want to try another words or sentence. Yeah, basically that's it. If Miss want to, if the Miss Sarah want to try like another words or sentence, I'll be typing it immediately.
Let's try anjing mengejar kucing.
Anjing mengejar kucing. Jadi
anjing
ID itu
anjing mengejar kucing.
Yeah, because like the result itself is underwhelming. Of course, like sometimes the translation model can output like gibberish, can output like gibberish words or sentence because it's still not perfect to me. Of course, like the longer the sentence is, like the harder for the language for the translation model to come up with a translation, because at the end of the sentence, basically it loses like the capability, like the more longer the losses its capabilities to remember all this context from the early times that like usually. Coba try longer words, like longer words. Wait.
Saya melihat kucing makan ikan.
Saya melihat kucing makan ikan. I saw the fish. It outputs gibberish word. Yeah. Basically, the AI model is still not perfect because of the bad quality data. And also, yeah, the longer the sentence is, like the harder the translation model to come up with the translation because it loses the capability to remember the context from the early time step. That's the common problem of all translation model using like the neural network. I think that's all.
Finish?
Yeah, finish.
Okay, yeah. Thank you so much, Vincent, for doing the presentation and the demo. Now we will continue to the question and answer session. Yeah. How are you today?
Hotness.
Hot.
Yeah.
Yeah, it will be nice because you can reduce your weight.
Sweaty.
Sweaty. Yeah. Okay. Just wondering about the terms that you use. You mentioned before about underwhelming performance. Would you mind to explain to us what is underwhelming performance?
What I mean by underwhelming performance is the final result from the all this overall result from the loss rate, and then the loss rate, the blue score, as the blue score guideline is rated as almost useless. Like yeah, that's basically what I interpreted as underwhelming performance. And the Grammarly also scores 19 out of 100. Yeah. So the overall score of this.
Okay. Are you create that word by yourself? Underwhelming.
Yeah.
It will very nice. Yeah. If you create new jargon, you mentioned before you use it. What is underwhelming performance? Yeah. So all of us will understand what it means. Or it will nice if you can change it to the normal wording that we usually use.
Okay.
Yeah, because if I Google it, underwhelming performance, I cannot get anything. I only can see what is underwhelming. Yeah. No combination between underwhelming and performance. Yeah. Okay. Please use the normal word. Yeah.
Okay.
Okay. That's the first note for you. I like. Yeah. You have done a lot of research. Yeah. In here. Yeah. If you have looked in your aims and benefit, yeah, you mentioned about this thing. Your first aim to reduce miscommunication due to language barrier that could happen between viewer to viewer and viewers to streamer. What do you think? After you done your thesis, have you achieved this aim or not?
I think I've achieved because I've already created the transition models, but it's still not. But in terms of the quality, it's still not usable for the trend. Usable by the live stream chat transition in practice to be used to translate communication between streamer and the viewer. Okay. But it has already achieved the core objective of it, which is like creating the transition model itself to serve as the service.
Yeah, please have a look in your aim because you mentioned about this reduce miscommunication to language barrier. Okay, based on the demonstration that you already provide to us, you haven't achieved that. You haven't achieved it yet. So it means even your thesis fail. That is very overwhelming. Or it will better if you change your aim so it can meet things after you got, after the result, you got something right, so it meet the end result of it, so it's line from start until the beginning of from start until the end of it. I recommend it to change it.
Modify the benefit.
Okay. Modify your aim. Okay. Because the end result of it, kind of overwhelming.
Okay.
Yeah. Okay. Next about chapter 2, yeah. Because you mentioned about ASCII, live stream chat, language translation, two-way translation. It will better if you put about all of those things, the general terms, in chapter 2.
Wait, which
ASCII.
one? Which one?
Live stream chat, chapter 2.
Chapter 2.
Yeah.
And
You jump only to the technical part, but how about the things? I mean, the topic that you discuss in here. For example, live stream chat, language translation, two-way translation. You need to mention about those things in chapter 2. Yeah, this is for your revision if you pass. Okay, next you mentioned before about hyperparameter. What is hyperparameter?
The hyperparameter basically the direct parameter from the direct parameter that the author directly modifies. The common term for in this study is the hyperparameter, and any other study. For example, like the learning rate is the direct parameter that the authors can modify, and the learning rate schedule, the layer, and the size.
Those things are the example, but what is hyperparameter?
But sorry, I don't get what you mean by it.
What is hyperparameter?
Hyperparameter, hyperparameter is the top parameter, from the AI model that the author directly modifies.
What is top parameter?
The top parameter, like the direct one, the parameter that the authors directly modifies. Basically, that's the core essence of the hyperparameter, the core meaning.
The core?
So, the core, like the essence of the hyperparameter is the parameter that the author directly modifies, such as like this, like the layer, the learning rate schedule, the learning rate, and the teacher forcing. This is a hyperparameter. So that's basically the explanation.
Those are the examples that you explain by using the examples. I think it will better if you can put about hyperparameter in chapter 2. For hyperparameter, I need your help to have a look on the reference that discuss about hyperparameter. We already know about, this one is hyperparameter. How about the proper explanation? I need your help to have a look on the reference that discuss about the hyperparameter.
Okay.
You can explain the example of it very well, but before you use the hyperparameter in chapter 4 and 5, it's very nice if you can put it the theory first, so all of us will understand about it. Next, about optimum solution. What is this?
Wait, which one is it? Optimum solution. I think it's wrong here. I think the optimum solution basically like the final answer, like the final wave value that can be used by the transition model, like to solve all of the problems in the data set. Like basically it's the final optimum solution, like the wave values that is used by the model to solve all of the problem in the data set.
Okay, please don't forget to put it in chapter 2. Okay, because it's very important. Same as hyperparameter, because you use it for your next chapter. So you need to find about what is optimum solution in chapter 2. Next, move to chapter 5. You mentioned about this. The model has not reached the optimum solution for the whole data set. And after that, you mentioned about noise. Do you have any idea how to remove the noise?
For removing the noise so far, yeah, I haven't find any way to remove that data that impacting the quality the performance result. Yeah, because like at the pre-processing, I don't include like any ways to filtering the data to remove like the bad data except the noise data. Yeah.
So you didn't use any data pre-processing to remove the noise?
Yeah, pre-processing. There is pre-processing, but there is not like selective pre-processing to remove like the bad data, like the noise data itu.
Okay, how can you classify? Oh, this one is the bad one. This one is the good one.
So how to classify? For how to classify sih, yeah, I also haven't found any way to classify the data. But from my understanding, the bad data is like when, for example, like the data consists of like A B A B A B A B gitu, and then there is like one data, let's say for example it's data Z, like the Z, this is like the noise data, like that is like different from the rest, and then that is the one that hinders like the model from achieving like the solution for all of the patterns, because this one single pattern like stands out from the rest, and it's different compared to the rest. Yeah, basically from my understanding that is it.
Okay, yeah. Please don't forget to put it in your document, because it's important. Yeah. In chapter 5, you mentioned about noise, so it will very nice if you can put more explanation about noise. Yeah, about noise in text. Yeah. Just wondering about training iteration that you use. Yeah. If I have looked on each case A, B, and so on, you use different training iteration. Any reason why you use that?
Sorry, like I don't get which topic that this talking
Each
about.
Case A. How many training iteration that you use?
Setting A, like the
training
chapter. Wait. This one, like setting A of the model.
Yeah, training iteration 100. In the other case, I can find 600.
Yeah, in another case, there is a 600 iteration.
Why use the different training iterations?
Yeah, because when doing the experiments, conducting the experiments, the authors try to find like the settings that gives the higher result, the better performance result. So yeah, it starts from lower training iteration, and then the author experiments it by increasing the iteration process to see if there is any difference between this 100 and 600. Yeah, it's like trial and error.
Trial and error. Okay. So do you have any idea when you need to stop the training iteration?
When stop the training iteration, basically like when it's getting the overfitting behavior, when the train set is gives good result, but the train set like get higher instead gitu, like the graph is like gimana for example like like this one, yeah, like this one itu kan like the training iteration is better to stop like this, because like if it continues, the loss rate will be like will be more like overfitting, like the train set and the train set will get lower, but the development set and the train set will be higher instead of going down also. Yeah.
Okay, for this
that's basically the answer.
Okay, yeah. For this result, have you tried to use 700 training iteration?
Sorry?
For this result that you showed to us, have you continue do the training by using 700 training iteration?
The like using if I continue from this setting and going to 700, for example, like it takes like a long time, a very long time, like to finish the process, and simply like the hardware cannot keep up, and like it doesn't mean that it cannot keep up, because like the Google Colab, it has like a quota, to be used, like how much, like how much the maximum limit that this one user can use like during the training process. And
Okay.
700 is like going to take so much, like too much long time, so much.
Okay, how about 610?
610.
Have you tried 610, perhaps 620, 605? Because before, if your graph showed the overfitting, you need to stop it. But my question is, have you tried to pass the 600 iteration? Is this benchmark, is the correct one or not? If you haven't passed it, you will not know.
Like if I try to pass it, like this one will certainly will go lower, but this one will go higher.
Yeah, my question is,
if considering using the same setting but increasing the iteration.
Yeah, my question is, have you tried? Because you cut it in 600 iteration.
No, I just cut it when I see the overfitting behavior is getting like escalated like quickly. I just cut it, and I haven't tried like the 600, because it will just it will be like much more overfitting this 300 than 350.
Okay, based on iteration, number 200, we can see, oh, it's overfitting. Why you continue till 600 and cut it at 600?
And the result, I'm sure it will be certainly, despite I haven't tried it, but because like that is the behavior of the learning process itself. The training process goes lower, and this one will be like getting higher instead of going lower, if assuming using the same setting but increasing the iteration.
Yeah. The starting point, if you have a look, the dev set and test set getting higher from iteration number 200. Why should you still continue? That is my question. What is your stop point? Why you decide, oh, I need to stop at 600? Why don't 200, 300, 400? The training, the time will be shorter rather than you train for 600. Because previously you only use 100.
The stop point is the stop point for stopping the training process is when the loss rate is getting overfitting, like exactly what I've mentioned before. When it starts to do like this, like for this, for example, it gets overfitting, then it is time to stop the learning process, because otherwise it is useless to continue.
Yeah, but we can see, we can see this after iteration number 200. Why you don't stop it at 400 or perhaps 300?
What setting are you talking about? Like
that one, the previous graph. The previous graph, sorry.
This one?
Yes. From 200, we can see that the dev set getting increased and the test set, still increasing. Why didn't you stop it at 200? Why you still continue until 600 and you use 600 for your benchmark? Oh, this is the stopping point.
Oh, okay. Because like it's a compromise between like this, the overfitting behavior and the higher result of the blue score ini sih. Because the blue score in as opposed the blue score is getting higher, but it's like a small quantity, and this one is getting overfitting, because like it's a compromise between loss result and blue score. And I think like it's best to stop at this, because it will be like getting overfitting.
Yeah. If you continue 700, will we have the same result? Yeah.
We'll probably we have the same result, but in just in greater scale, like because the iteration doubles.
I understand. But my question, why you still, you can see the overfitting on some iteration number. But my question is, why you still continue the things? You already know, oh, this is overfitting. Why you still continue the iteration until 100? I need the reason behind it, because previously you only use 100, 600, and in here 600. Okay. I need your help to provide the information about the training iteration, because this one is very important. Yeah. Okay. Next question about LSTM. Just wondering, because you mentioned about LSTM and you compare it with vanilla RNN, how long LSTM can store the memory? With the vanilla.
Yeah, like the LSTM itself, like the concept of LSTM, like it doesn't specify directly how much content that it can be stored. Like it depends again on the implementation of the solution from each of the study. So yeah, each study, even though they use LSTM, the result for the remembering the context and everything so on, and leads to the performance result will be different. Yeah, like it doesn't explicitly stated how much that that the LSTM can remember in the concept itself.
Okay, yeah. Please don't forget to put that explanation in your document.
Okay.
Yeah, because this document is the scientific academic paper. So every time you would like to use it in your document, you need to explain it first. Oh, I'm gonna use this term. So you need to explain the term first before you use it. Yeah. To help all of us, you have done several tests, right? Yeah, it's very nice if you can sum up the test result using the table. It can help us. Test 1, test A, test B, test C. What's the result? Instead of you separate each case in different table, you can sum up in one table. Yeah, test A, test B, test C, and so on. Yeah. Okay, I think that's all for the detailed information regarding my text. You may find it in the revision note. Yeah. Thank you. Good job.
Thank you, Miss.
Yeah. Next, Rosatrio, are you there?
Yes, I'm here.
Okay, please go ahead.
Hey, Joyan, how's it going?
Good lang.
This is a quite complicated thesis, and it's I think it's kind of mind blowing that you made this. Okay, as usual, Miss Sarah already gave a lot of feedbacks. Just to add a little more icing on the cake. Agree with Miss Sarah in chapter 2. Please add more terminologies that you actually use, the basic of the any techniques and terminologies like ASCII, like Ms. Sarah said, just put it in chapter 2, right? And then we can add what translate means, translations. And then in chapter 2 also add I think you didn't have any methodologies in chapter 2, is it?
Sorry?
Methodologies.
The methodology for research.
Yes, in chapter 2.
Oh, I've put it in chapter 4 because like for AI style for AI research like this, there is no like it's unlike the software development. AI study doesn't have like the standard like AI for doing this about research methodology, as AI research can be different from one study to one study. Yeah. It's like in the nature of the AI research itself. So therefore, like the research methodology uses I use like my own research methodology, like to come up with this thesis.
Okay, can you put that in chapter 2?
Chapter 3.
Yeah, chapter 2.
Oh, chapter 2. Oh, so I put this also in chapter 2.
Yes, that's your research methodology.
Oh, okay.
So in chapter 2, and then your system architecture. Can you please explain it again about your system architecture?
Which one? This one, yeah.
Which one? Yes.
I think I've already explained it in the theoretical foundation, because the theoretical foundation, like the neural machine translation and the evaluation technique, I like that consists the details of this architecture, like the use of nuclear neural network and the training itself process and the sequence to sequence and the long short-term memory, network. Yeah, it's already the long explanation version of this one proposed solution. This proposed solution is the condensed version of this, like the less complicated one. So if I put this in chapter 2, like it will be kind of redundant, is it?
What in chapter 2? What do you mean?
So yeah, it will be kind of redundant because like this is already the condensed version of all this explanation from the recurrent neural network and so on, because it explains like each of the feature that are used in the proposed solution, like using the recurrent neural network and the training to be used, and then the sequence to sequence. Like it's already the long explanation of this any proposed solution. Like from what I see, if I put if I put the proposed solution here again in the chapter 2, like it will be kind of redundant, sir, like in my opinion.
I'm sorry. If you put what do you put in chapter 2? That will be
the long version of explanation, like because like this one, it uses basically like the condensed version, the less complicated version, like all the summing up version of what features that is used in the architecture. And the chapter 2 is the long version of explanation for each of the feature in the proposed solution. So what I get, the Sir Satrio want to put like this less complicated version, like the proposed solution in the chapter 2 kan.
Yeah, but not the system architecture, just the research methodology.
I thought it was this one also put in the no, because it's kind of redundant.
No.
The research methodology.
Yeah, I'm asking. Before I was asking you to put the research methodology in chapter 2.
Mm-hmm.
And then the next questions, I'm asking you to re-explain the system architecture in here, right? That's it. That's the only thing that I asked so far.
Re-explain in the chapter 2.
No, I didn't ask about chapter 2.
Actually, I can lost because because the connection is bad. I can lost. Like what do you mean by re-explain that? Like do I need like to re-explain it
to me?
Re-explain it now.
Paper. No, I'm not asking you to explain on the paper because you already did. I'm asking you to explain it to me.
I thought I need to explain it more in the paper. Yeah, the system architecture, it works by this one. Like it is a very delicious food, right? Because it is sequential data processed serially by the neural network. It's divided into a sequence of word tokens, and these word tokens at the end will be converted into one hot encoding vector, like 100 or 0100, depending on the location on the vocabulary. In the vocabulary, and it will be fed to the LSTM cell the first time step input direction. The top one represents the left to right, and the bottom one represents the right to left. And then after processing it, it will result the result will produce the hidden state, and the hidden state will be transferred to the next to the next LSTM cell or the next time step. Next time step this LSTM, the next LSTM cell, and then the process will continue until all of the words in the tokens in the sequence ini are fed to the neural network. And then the final hidden state from both direction, it will be transferred to the decoder. And then the decoder also applies the bidirectional for both direction, and it's fed with the start symbol. So to signify the decoding process, it uses start symbol, which is already converted into one-hot encoding. And then the final result for this proposal for this LSTM cell both direction, it will be concatenated into a single hidden state containing information from both direction, and then concatenated further with another information from the attention mechanism, which is the information gotten from the encoder, hidden set of the encoder. And then it will goes to the it will outputs the prediction result, and this prediction result will be used at the next time step. So it's like one by one, this outputs the result, and this is put into the next time step, and then this outputs until the end symbol is found. And because it uses teacher forcing to speed up the learning process, this ground truth input is used instead, because this one at the third time step is incorrect prediction. So it's to speed up the learning process. Instead of learning from the incorrect, it learns from the correct answer instead. But the final answer will still be uses the incorrect one. Yeah, because learning forcing is just to speed up the learning process. Yeah, itu the proposed architecture-nya.
Okay, thank you.
Okay.
Joyan, which one is this based on your illustration of the proposed architecture? This is all your scope, right?
What scope?
Scope.
Oh, scope, yeah.
So which one is your partner's scope?
Partner scope, it is outside of DC, like the web application.
Okay. Can you please add the complete system architecture that has your scope and your partner scope, so the reader can actually read, this is what you actually doing, but in this chapter, this is only your scope. So put something in color to identify your scope. You think you can do that?
Okay. So I also need to put like the I think like the web app architecture from my partner, from Jason, and put it together with my architecture.
Yes, so this is the big picture of the, what you should add is, what I'm trying to say is, you put a big picture of the system architecture, right? That consists of your scope and your partner scope.
And I highlight my architecture.
Right,
Okay.
so the reader knows that, okay, this is actually connected, and this paper is talking about this scope.
Okay.
Okay. Now to chapter 5. Now, where's the? Can you please add the development hardware, the software and hardware that you're using? Okay, so the hardware and software specifications and requirement to developers, and then the hardware and software specification and requirement when you actually want to implement this to the server.
Okay.
Okay.
But the hardware uses like the hardware from Google Collaboratory, and the Google Collaboratory like as far as I know, it doesn't disclose like what the detailed hardware that the system uses in the Google Collaboratory.
Okay, so just put the one that you, if it's not, there's no more information about that, just put it the one that you know.
Oh, okay.
Okay. So and then what's the accuracy percentage of your translation program?
Accuracy percentage, kalau based on the Google Cloud guideline, it's because it is rated using the blue score, and the blue score is less than 10. It is in percentage. If we translate it to like this blue result 0.05, so it means like it's 5%. So yeah, it is rated at below than 10% or almost useless.
So below than 10%.
Yeah, below than 10.
Okay, and how about the limitation of your translation? This program.
The limitation.
Is it possible to translate slang language?
Slang language it's not possible because of the slang language like the slang words it's not possible because the dataset doesn't have any slang words. And for the how accurate the translation is this is like the like itu like the the standpoint, bukan like standpoint, like the to see like to see how accurate using this one sih intinya like the blue score like for it doesn't have like any other lupa kayak things like to use to be used as the hard to describe like like the final result is presented in the blue in the blue score and the blue score like translate like the performance result sih intinya itu sih like the essence of what I
not possible for slang words
like kalau slang words it's not possible.
Okay,
kalau for the case of slang words it's not possible.
When you watch not sometimes, most of the time when you watch the live stream, they're not using a proper word, you know what I'm saying? They using the conversation words, which is more
more informal, like.
Yes, exactly. So that's probably did you put that in your
I've already put it in the constraints because like the constraints like is finding the appropriate data set to support like that kind of translation, because like when I try to find during data collection, I haven't found any suitable data set to directly source from the live stream chat log, like like using slang words, informal language, and so on. And therefore I use the alternative data set from what is available in itu out there. I've already put it in the constant.
Okay, according to your demo, can I see the demo again?
Still on it.
Okay, it seems like the word kucing is missing, always missing. Can you try to use the word only kucing word? Is it going to be translated?
Salah sih.
You go.
ini bener ini bener nggak sih? Nggak. Ini inputnya bener kan? Benar sih. Kalau IDN kan anjing atau enggak, kalau misalkan anjing ini benar nggak sih urutannya? I input apa ya? Oh, ini kan komen. Oh, komen. Iya, komen kan dulu kan. Kalau ini output. Bentar. Because
Are you talking to me?
Benar. I'm talking to myself. Nah, ini.
Okay.
Ini IDN. Kan kalau I'm just checking if I input the correct one from the if case. Oh ya, benar, correct one. So tadi apa sih? Kucing. Kucing. IDEN ya, IDEN dulu. Kucing. It doesn't give like any translation.
How about anjing?
IDE lagi ya lupa.
ID-English.
Yeah, it doesn't give. For example, coba. Yeah, gibberish. At the end, it's all about gibberish because the I don't know the low performance the resultnya.
So
Gibberish.
I mean the only if you put it on, if you translate only one word, not gonna work.
Like like apa? Sorry, like what kind of word?
One word, like kucing, anjing, manusia.
Kalau saya.
Why is it? Why
IDN.
it didn't work?
Yeah, like saya, I am. Like sometimes it gives the correct translation. Yeah. That's the quirkiness of translation model. Like if the translation haven't reached like the like what I said, like an optimum solution from the data set, finding like the right loss value against all the patterns in the data set. The training model, in other words, will the learning processnya itu like it's not in the in the optimized word, bukan in the optimized, in the in the maximum resultnya kayak so that means like the kucing, like maybe like the translation model haven't done it like very well, the terms kucing, maybe because it can be because like the kucing words itself is rare in the data set, or maybe like because tadi the model haven't reached like the solution for the kucing word itu, like the pattern of kucing.
Isn't it supposed to be the data set provided the basic words for every single word? Like,
the
dictionary.
data set. The data set. It provides a dictionary, but it's just the dictionary only sense of the dictionary. Like the AI itself like cannot comprehend like what is kucing, what kucing means. Like it still need to the AI model basically works on a series of pattern of all kayak a lot of pattern lah. And then the AI model like finds like the how to solve all of this pattern like in the optimum way, like finding the solution for that. And maybe because of that, like it hasn't seen the solution for the kucing this word, or maybe the kucing word itself is rare in the occurrence of the training set, in the occurrence of the pattern. Because the vocabulary itself is just a vocabulary from the human eye, but the AI model sees it as a pattern. Like that's it from my understanding.
Okay, so probably you should add that in the more detail in the constraint, or limitations. Probably, I don't know. Just discuss with your supervisor. Okay. All right, that's it from me. Thank you. Back to you, Sarah.
Yeah, thank you, so for the valuable feedbacks. Next, Ms. Nurul, any message for Vincent?
Okay, Vincent, well done. Congratulations. You finally reached the end of your thesis stage now. Answering the Sir Satrio question about the hardware, actually, for Google Colab, they give you the specs. You can find it in the documentation of the Google Colab. You can put it in your documentations. They mentioning about the GPU that they use, the core number, I think it's 2 core, the RAM, you can find it there. And yes, there is.
But it is ini cuma it only provides the, because I use GPU kan, Miss, it provides only the GPU.
You can search it, Google Colab specification, hardware specification. The one without Pro, right? Without Pro subscriptions. And then you can also mention the limitations as well for the hardware. Okay, and then answering the next question about the data sets, yeah. Yes, I think in the future you can recommend that you can combine with a single source of data sets like dictionary, like a normal dictionary, merge it together with your existing data sets. I think that will be improving the result. Yeah, I don't know, maybe. I think that's it from me. Well done. It's a very good job. It's a good experience for you as well. Yeah, to build the thing that you dream of, right? This is the one that you dream. This is the one that you want in the beginning, and finally you reach this. And now your job is to continue the research and yeah, improve it. I think that's it. Thank you.
Yes. Yeah. Ini for the result nanti.
Wait.
For the
what result?
Revision.
Wait,
ya?
you need to wait. Revision edition, you need to wait. Okay. That's all for the Q&A session. Vincent, you will be put in the breakout room. Ms. Nurul, would you mind to help me to put Vincent in the breakout room? Yeah. Thank you.